All right, well, people will keep on adding on as we start moving forward here. So our target again, we do these every month and a half or so. Excuse me. About 30-minute target today as well. Everybody knows what to do. You have computer and phone audio is available. And please stay muted. Do our best to get through this and ask questions at the end. So what we're going to be covering today is we're going to be doing a quick review on the key topics. The all-in-one is a very key topic. EMA versus SHA, some highlights there, and the all-important apples-to-apples comparison. SHA basics, the simplicity of it. We'll do a little deeper dive in the AOI. We'll also talk about a little more in detail regarding the force control. Talk about some marketing things we have going on and a couple applications at the end. So what's important to us compared to some of our competition is the no finger pointing, the all-in-one. So yes, we provide the actuator. Sometimes we provide the actuator all by itself. But in most of our applications, it's the all-in-one. I mean, the actuator, the motor is selected, drive, everything, the software, which our competition a lot of times is just the actuator alone, and you get a lot of finger pointing back and forth. Well, hey, the motor's not sized right, or the drive's not doing this, or the software is not doing that. We try to eliminate all that. So we're gonna up front resize the actuator. We take a lot of time up front to make sure we gather as much information as possible to make sure that we optimize the actuator. We even try to pass the old smell test, say, hey, if we're replacing an EMA or we're replacing a hydraulic power unit that has one actuator on it, one cylinder on it, there's a certain amount of power that's required to move. And when we do the calculations regarding moving a particular load from point A to point B, it takes 10 horsepower. And if you look at on the HPU and it's a 5 horsepower motor, it doesn't pass a smell test. So we have to dig back in, and somebody's enhancing some numbers a little bit too much. So anyway, we do all that up front. Make sure the actuator fits into the machine. We'll send models out. Make sure the motor, select the motor and drive. Make sure the motor fits onto the actuator properly. We'll do the electrical schematics as needed depending on your machine. Some are more complex than others. Some are simple. Drive sourcing, we'll do that. The software, set up all the parameters, the integration. Harnesses are sometimes a pain in the butt. A lot of times they are. We'll select the harnesses, not only for the motor drive, but everything else out there, the linear transducer, as well as the pressure sensors or anything else that's out there. Harness production, harness testing, we'll do all that in-house as needed. Field bus integration, mapping, all the standard things, do all that for you. Standard programming, documentation, test, all in-house as much as we can in order to make sure we test as close to the application as possible. So the only finger that's pointing is at Kyntronics. So this is an important aspect that we offer. EMA versus SHA reliability, another important part. This is just a press example showing that a lot of applications, you're applying a particular force, as you're seeing here. The force is being applied now, and the same gear train is getting applied. You don't have that with hydraulics. There's no metal to metal, there's no gears. So again, you're getting now those two red gears placed every single time that this press is applying a load, leading to premature wear. Other things that are affecting the EMA's life, loading. Higher the loads, the lower the life. The SHA is not load dependent at all. Impact shock loads, EMAs, don't like that at all. The SHA hydraulics, they encourage impact shock loads, no problem whatsoever. Side loading, EMAs, they can't deal with any side loading. SHA can. There's ways to compensate for some side loading. Of course, you try to avoid as much as possible, but you can't always avoid it totally. So there's ways to compensate. Lubrication, a lot of times actuators, EMAs get placed in the factories. People tend to forget to lubricate. It's always an issue. There's no lubrication with the SHA at all. It has hydraulic oil inside of it. No lube required. Liquid ingress is always an issue with EMAs. A lot of times they're rated as static. When they start moving, they lose their IP rating. The SHA is IP65 out of the box. No issue with the ingress protection, of course. A few other things, no brake required for an SHA. SHA uses check valves, relatively simple. EMAs have a brake and power, as well as coordinating the brake, turning on and turn off at the right times through the software. High force densities with the SHA, versatile configurations. We'll get into that in a little bit more in detail. Force control, we'll also get into some more detail. But regarding the EMAs, you have to have the load cell and amplifier, etc. Reliabilities, much more reliable solution is the SHA over the EMA. Side loading, impact loads, ingress protection, all kind of issues with EMAs. The apples to apples comparisons, another important part when we're out there selling these things. So if we're selling to Sarah, the procurement person, say, hey, Sarah, how are we looking? And she's telling us that we're $3,000 more. You got to dig in a little bit further and say, Sarah, what is the $5,300? Why are we that much more money? What's the competition providing? And once we dig in, it's just an actuator alone. Well, she comes back and says, okay, I got a price for the motor drive, and now you're getting closer. It's still not the same. Again, we provide the all-in-one solution, fully tested, everything's there. The standard software, all the features are applied as needed for the application. The load cell and amplifier, again, for a small little option, that's included in our system as well. Reliability is another one of those intangibles. Much more reliable solution, more uptime, that leads to more money in the pocket for whatever applications out there running. So SHA basics, just wanted to share some of the basics with the SHA. How does it work? It's really a simple design. This is one of the main reasons why it's more reliable, because of simplicity. You run in one direction, the red, put fluid into the red, the actuator extends. Run the other direction, put fluid into the blue, the actuator retracts. Again, it's simple and basic. There's not a lot to go wrong, which again leads to that more reliable solution. Hydraulic fluid, very efficient, no mechanical binding wear items. It's a very efficient actuator. No hoses, no thread connections, totally sealed, totally enclosed, no air. Any orientation can be applicable for the actuator. Simple hydraulic circuit. Optional valves, again, check valves, counterbalance valves. You have your relief valves on every actuator. That's to protect the actuator as well as the equipment as needed. Optional pressure sensors, 4-quadrant control, servo control. Again, try to keep things simple. Product configurations. All kinds of different product configurations, as you can see here. This is the beauty of hydraulics, again, taking advantage of it. It's just moving fluid. You can't do this with mechanical, gears, etc. You have your parallel, your inline, 90 degree behind the power unit, metal, 180 degrees. You can also add the enclosure to the actuator, all in one, 24 volt DC solution, enclosed motor and drive inside here just to have electrical connections. We can provide, of course, the actuator all by itself, no motor, customer supplied as needed, or something custom as desired. Mounting options are all popular mounting options available out there for the rod, actuator mounts, various feet, flans, rear, all your basic, and as well as custom. If you need something custom, we can do that as well. A lot of applications, you say, hey, you got a hydraulic solution that's frowned upon. The response to that is that there's not a lot of fluid inside of our actuator. That's the key. So for an 8-inch stroke, 10,000 pound force actuator, only a couple cans of Coke. So in a worst case scenario, you have that tow motor run over the actuator, you just get out a mop and no environmental major catastrophe. Even a 5 horsepower gearbox with an electromechanical actuator has more fluid in it. And of course, the HPU has a ton of fluid in it. So minimum risk. Force control. So this is an important slide showing the mechanical advantage on hydraulics. Really taking advantage of the hydraulic concept. Your area is pi r squared, of course. Force is area times psi. As you're going up through the diameters of the cylinder, you have a lot of increase in force capabilities. So just for example, your 3 1/4 inch is 25,000 pound force at 3,000 psi. 1 inch, 2,300. So you're going 3 1/4 times increase, going from 1 inch to a 3 1/4, and the force increases 10 times. So a lot of nice force density. Plus you got a nice smiley face. EMA versus the SHA regarding the cost. This is an important aspect. We're competitive down here on the lower end, especially in the all-in-one, all-inclusive solution using our standard software, etc. You get above that 5,000, 10,000 pound force and even further up, it's 2, 3, 4 times less expensive than EMA. EMAs are massive. They get complex and inefficient. EMAs have stroke limitations regarding their larger actuators. The SHA does not have those limitations. So again, a lot of times, and several OEMs out there, they want to replace their hydraulics and say, I want an electric solution. It's very expensive for the larger 30,000 pound, 40,000 pound force actuators. They can't afford the EMAs. That's where the SHA comes in, and it's a huge advantage. So force control, what's it used for? Surprisingly, a lot of our applications is force control. A lot of presses, a lot of testing applications, process control, etc. It's just not point-to-point, A to B, position control. So taking advantage of the force control of the SHA. So force control with the SHA can be used in any direction, extend, retract. It can also be used with position as needed, going back and forth between position and force seamlessly. So how does an EMA do force control? Well, it's got to use, as mentioned earlier, the load cell, amplifier, harnesses, etc. You need power for all that. So we need to integrate the software and support and all that non-standard things. For the SHA, all you have to do is add this simple pressure sensor. So some basics. Area, pi r squared, we all remember that. Force is area times psi. Another important part of the speed, if given a certain gallons per minute flow into your blue or red, that divided by area is your speed. Some of this is going to be pretty basic for some of you, but hopefully they'll be a little bit informational for others. So regarding the area, we're talking about the area of the piston. So area again is pi r squared. Force is your area times the PSI. You can even say it's minus the F2 pushing on opposing the piston itself, but usually that's pretty negligible, and we'll just get rid of that. Keep things simple. So really your force, extended force, F1, is your PSI being applied to the area of your piston. Pretty basic. Your speed. Speed is determined based on your flow of your pump divided by your area. So your area affects your speed. So as your area increases, your speed decreases. A2, the opposite side, you have a rod portion of it. So area is D1 minus D2, so your area A2 is going to be less than your area A1. Same thing with your force. You can even say, get rid of the F1, keep things simple. So your pressure applied to the area available for that pressure is your force. Same thing with your speed. As your area decreases, your speed goes up. That's an important point that with hydraulics, it's a nice feature. A lot of times with most of the applications do not require a lot of load on the retract side. You're just moving fixtures back and forth. So on the retract, you have your increased speed. That's why you see some of the quotes, you see different speeds on your extend and different speeds on your retract. That all has to do with your areas are different. So you're going to have less force. F2 is going to be less given the same PSI than your F1, your extend force. But that's, in the majority of applications, that's just fine. And your speed, again, in retract is going to be faster depending on your areas. And sometimes we play games with increasing the size of the rod, increasing the speed even more to help with cycle times. So there are some basic formulas for you. Load cells. So yes, we have done load cells. We've done load cells with the SHA. Some customers request that, and of course the customer is always right. Why do they want load cells? And a lot of times it's in testing applications. They have to get these things calibrated, and for audits and things, it's easy to take the load cell off and get it calibrated and add it to the system. It also can be used for secondary monitoring, etc. So regarding the standard software, it doesn't matter. Use the pressure sensor or load cell. The standard software is always going to be used for the force control. It's all available. Going into some development items we have going on. The vector itself, give you some highlights there. Some of you that have the new sales demos, it's an all-inclusive Kyntronics solution. You have an early version of the hardware, and you're using the software as well. The production-like hardware is going to be available for us to start testing in November, December timeframe, and we're going to be hopefully getting some beta sites out Q1 next year. That's progressing well. Some other items that are in development, some higher speed capabilities. We're designing a new manifold. We've already purchased new pumps. We have some large motors. When you're talking about this big stuff, it's going to be really for the 4-inch, 5-inch, and 6-inch cylinders, the larger things. It's going to require large motors, etc., for to run the large pumps. we're already quoting these in projects as needed. Press package is also something we're looking at. We have all the pieces, parts. It's just one of those things we can put it together to go against ProMass, etc. out there. It's a little deeper dive into the AOI. It's a simple setup, same software that I've been talking about. All that was imported into this AOI to be run with the Rockwell control, position control, force control, and position with force limiting. Activity from your position sensor, you can do Ethernet IP, a half axis, goes into the drive itself, 0, 10, minus 10, all kinds of different options for your position sensors. You can bring it in at a PLC as well. Force thing, you can bring that into the PLC. You also have your motor connections as needed. It's just a high level connectivity regarding the hardware. Quick little summary, the AOI can only be used with Kyntronics equipment. The AOI is specific to the Rockwell hardware, and it cannot be used on any other PLC or drive specific to Rockwell. And it's available for use today. A quick little video. It's a 5,300 pound force actuator. You can see how, and this is force, this is the AOI working right now. So it's very sensitive. Again, 5,300 pound force actuator. That shows you the, again, the AOI in operation. A few things regarding marketing. New materials being added every week. Success stories, I encourage you to check it out. Also check out new videos. There's 6 new videos are out there showing actuators in motion, in action, on machines, hydroforming, lumber, packaging, assembly, coin and piercing, as well as a combination of all those. So if you have a packaging application, grab the video out there, send it to your customer. Updated PowerPoint, of course. Continue to do the SEO, drive leads, and we encourage you to follow us on LinkedIn. So a couple applications, again, the same story, central hydraulic replacements. We do a lot of those. We're getting more and more, hey, I want to go all electric, get rid of the hydraulics. You guys are probably seeing that out there as well. And we're also replacing those electromechanical actuators that have challenges out there that may have already replaced some hydraulic systems and are failing prematurely. So this application is for a battery frame fatigue tester. This application was a 12,000 pound force actuator, low frequency fatigue test, force control. They wanted accurate force control through a low frequency and wanted to be able to step it up and step it down to various levels. They requested the use of a load cell in this particular one. Accurate position control, accurate force control is what they were looking for. Just to give you an example here, this was really tracking pretty much on top. You have your reference in the blue and your feedback in whatever other color that is. And you can see it being stepped up. It's tracking almost perfectly as you step up from one force to another. And the frequencies, excellent response. So this particular one was for, again, a battery tester for the batteries. They expand for the most part, contract a little bit, so the frames will see all kinds of fatigue, and that's what this particular actuator is out there and testing that. So this particular application is for a coordinator roll lift in the rubber industry. 2 16,000 pound force actuators, all in one. Coordinated servo control, Ethernet IP. The important part is that these 2 actuators are removing a roll, one on each end of the roll itself. Large roll. You see here, these things are being synchronized. You've seen this before. Sorry for the jerkiness, but just again, simple synchronized digital lock solution to 16,000-pound force actuators. Accurate position control is absolutely required. So that's pretty much it. We're wrapping up a little early. So it's an all-in-one solution, making a complex simple, versatile offering. It is the most reliable and efficient actuator offering on the market. Very cost-effective solution. Force control, keep an eye out for those type of applications out there. This actuator is ideal for those applications, press, etc. And definitely follow us on LinkedIn. Any questions?
Hey, Carl.
Yeah.
I just want to jump in and a very nice job as always. But just a quick clarification on a misconception that oftentimes comes up when we talk about us being able to provide the drive and do the integration of the servo drive. That only applies to the products that we provide, not the third-party drives. So we're not an Allen Bradley integrator or a Siemens integrator or Yaskawa or Omron or any of the other brands. We'll certainly provide you with the adapter plate. We'll provide you with the speed and torque required for that motor if that's what your customer is specifying and that's what they want to use. So I just wanted to throw that out there. So we have obviously the Control Techniques drives. We also use some AMC products for the low voltage DC, and then when we release our new vector drive. The other point I just wanted to mention when you were talking about the limitations of the EMAs, the screws on the strokes, I guess we're really referring to the stroke length. So it's not just the force that drives up the cost, that oftentimes when you start getting into the longer stroke lengths, that really drives up the cost of the screw, but it doesn't impact our price as much. So we get really competitive on the longer stroke length applications. And then the last thing I just wanted to touch on, even though we can certainly use the external load cell, that is a pricey option. So if we can help eliminate that, I mean, I've just learned recently on some of these test applications we've done that those things cost anywhere from $1,500 to $5,500. Then of course you have to wire it, power it, calibrate it, do all that sort of complicated stuff. So if we can help you eliminate that by using these inexpensive transducers that reliably and repeatably and very accurately give you that force control, that's a win for your customers as well. So just thought I'd throw those in, but otherwise really good job, and I'll turn it back to the field.
Hey, and then Carl, this is Rick. There's a couple questions in the chat screen. I don't know if you wanted to address those or not.
Okay, I just opened it up.
So the two-hand controls, that's no problem. Certainly we can wire that in. We've also got safe torque off as a standard input to the drive to disable power to the power component, so there's no motion, and yet you can still keep your control logic powered up so you know what the status of your machine is. If you want to talk in more specifics, we'll gladly, show you a diagram on how we would wire it in for two-hand control. And then the question about the where's the energy or the power coming from? It's a power on demand system, so it's only energized when you actually put torque on the motor or apply current to the motor, and that's when motion is commanded. Otherwise, it's not using any energy, and there's no stored energy in the cylinder or the system itself. We do actually put a small amount of pressure in the cylinder before we seal it up, and that helps obviously keep it totally closed and prevents anything from being drawn in past the rod seal, which helps a bunch, but otherwise no stored energy in the system, in case that answers that question. And there's a comment about our wording about safety for press control applications. So the safety circuit is something that we always leave at the engineering team on the customer side, but we'll gladly discuss what they're trying to accomplish and what their safety circuit is designed to do, and then guide them on how we would obviously wire and do the control inside the drive if necessary. Fair enough?
Another one
Then
just
there's a question.
regarding the an event of a breakdown. Yes. So if depending on what happens out there, obviously we'll try to debug over the phone first. But if there's something that cannot be fixed over the phone or possibly in person, then yes, we'll have to send a unit back and we'll diagnose what happened and give you a report.
If it's been damaged, right.
Right. All right, gentlemen and ladies, thank you for your time. If you guys have any other questions, feel free to reach out to your sales guys or any of our channel partners, and we'll help you out as we can. Again, thanks for your time, and we'll see you next time.